let us investigate the isotopic spin, flavor, and color charge of the C-quark decay. First, let's look at the isotopic spin of the generic U-quark and the neutral bosons composing the C-quark. First, we have, for the generic U-quark, we have 1, 6, 1, 6, plus 1, 6, which gives us 1/2 for the isotopic spin. And then we have on the boson 0 that is composed of a flavored anti-T, we have minus 2/3 plus 1/3, which is minus 1/2, which cancels the plus 1/2 on the generic U to give us an isotopic spin of 0 on the C-quark, which is what is indicated by the standard model. Of course, the particle-antiparticle pair here has no isotopic spin, or the isotopic spin of the constituents cancel. Now, if we look at the S-quark product of the decay, then again we have the plus 1/2 of the generic U-quark, and then we have on the boson minus, which transforms the generic U-quark into the S-quark, we have minus 1/3 and minus 1/6, which is minus 1/2. And so that minus 1/2 cancels the plus 1/2. And we have again the predicted or required isotopic spin, isospin of 0 on the S-quark. Now let's take a look at the W plus particle that is emitted. On the particle-antiparticle pair, these V rishons, we have 0 isotopic spin. On the boson plus, scalar boson plus, we have a 1/2 isotopic spin, and then on the boson 0 that's carried over from the top, we have a minus 1/2 canceling the plus 1/2. So again, we have an isotopic spin of 0 as is required by the standard model. And of course, for the anti-C-quark, just as the C-quark above, we have the corresponding anti-quanta of the isotopic spin, which is what is expected on the part of the standard model. Okay, so let's look at flavor. And so the flavor on the C-quark is provided by the flavored anti-T rishon, which gives a flavor quanta of 1. And if we look over here, we have flavor quanta on the particle-antiparticle pair that cancel. And then we can look here at the S-quark, and we see that the anti-V flavored rishon, which we received from the particle-antiparticle pair, provides the correct flavor charge for the S-quark. And we see that a flavor charge of 1 and 1 on the composed boson plus, and the neutral boson received from the C quark provide for the W plus to carry away a flavor charge of 2. Now, when this boson plus combines with the anti-C quark, we'll see that the -1 of the anti-C cancels out the 1 on the neutral boson, and for the new anti-S, we will have a flavor charge of 1, which is required by the standard model. And so for the flavor quanta are consistent. And color charge again is indicated by the right half of the semicircle, and we'll see on this V we have an orange, and on this T we have a blue, which cancel, and so the color charge will be given again by on the generic U by the charge on this T, which is red. And of course, for all combining components of boson zeros, the color charges cancel. And we can look here and see that we have the opposite corresponding color charges on the anti-C, starting here with a blue and an orange canceling, and leaving a green on the anti-T. And for the neutral bosons, the constituents color charges cancel. And let's look at the product. This S quark. We know that there is an exchange of a green-orange featured V Rishon for a purple-orange featured V Rishon, which changes the spin of the generic U quark. But otherwise, the color charges are the same. Orange and blue canceling and leaving a red. And the boson minus constituents having color charges that cancel. We can look now at the W particle, and as usually predicted, for constituents of neutral combinations, we have canceling color charges. And there we have the color charges of the decay of the C quark, again consistent with the standard model as we've seen. And if you want to look more closely, you can look at the individual quanta that combine to make up the color charges to check these combinations more thoroughly.